What's going on, guys? Welcome back to my channel. In today's video we'll be starting a new chapter, which is mechanics. By far the most important chapter in my opinion in the course of Extension 2 Maths. A lot of real life sort of problems come in a lot of these examples. The first subtopic we'll be looking at is forces and acceleration. Before we look into any of the examples, let's try and understand the general theory related to forces and acceleration. The first one I'd like to introduce is Newton's second law of motion, which is F equals to mass multiplied by acceleration. In order to calculate force equals to ma. Another one is acceleration and other forms of acceleration. So a lot of the times we know what acceleration is. It's the first derivative of velocity, and velocity is the first derivative of displacement. So dv upon dt equals to dv upon dx, correct, multiplied by dx upon dt. dx upon dt can also be written as velocity, because that's the first derivative. So another ways of writing acceleration can be v dx dv upon dx. So that's the first method of writing acceleration. Another method can be d upon dv brackets half v squared multiplied by dv upon dx. Correct? That is velocity over here. Gone. So this then gives me half v squared ddx half v squared. Second method of writing acceleration. The last method is, as we have dv dt, v dv dx, and this one over here. Last one would be d squared x upon dt squared. So we have four different variations of acceleration, as all of these are as important to each other. So keeping these in mind, let's look at the first example related to forces and acceleration. So looking at this first example, we've written down the different forms of acceleration over here, and we've written down F equals ma. EG1. A particle moves in a straight line given that at time t, its displacement is x and velocity is v. If x double dot, another way of writing acceleration is this. This simply suggests that x is displacement, x dot would be velocity, and x double dot is acceleration. So if x double dot equals to 3x squared, and v, so the velocity, equals to negative square root of 2 when x equals to 1, and when x equals to 1, t equals to 0. Find x as a function of t. So as we can see, we're making our way up instead of coming down from displacement to acceleration. We've gone acceleration to displacement. First step, relevant to this, I would say out of these four different forms of acceleration, this one appears to be the most relevant. So let's write that down. So we can go over here, d dx half v squared equals to 3x squared. Let's integrate both sides. We then get half v squared equals to integration of 3x squared dx. A half v squared equals to x cubed plus c1. First constant over here. this equation over here, when x equals to 1, v equals to negative root 2. Sub that in. Negative root 2 all squared would be 2 upon 2, which would be 1, equals to x equals to 1 plus c1. Therefore, c1 equals to 0. Therefore, half v squared equals to x cubed in this case. Further simplify this, we go v squared equals to 2x cubed, v equals to plus minus square root of 2x cubed. Coming back to this part here, this would satisfy when v equals to negative root 2 at x equals to 1. That means that the velocity is negative in this case, so we'll take the negative part of this. So v then equals to minus root 2 x to the power of 3 upon 2. Correct? You can write that as that way. What is v? V, coming over here, equals to dx upon dt. V equals to that. Let's sub that in over here. So dx upon dt equals to minus root 2 x to the power of 3 upon 2. Reciprocate in terms of x as a function of t. So dt upon dx equals to negative 1 on root 2 x to the power of negative 3 upon 2. Correct. Coming back over here, integrate both sides. We then get obviously dt equals to this, negative 1 on root 2. Take the constant outside. Integral of x to the negative 3 upon 2 dx. Correct? Next step, t equals to negative 1 on root 2 multiplied by, we add 1 to that and bring it out in front. So adding 1 to that would be plus 1, 2, we get 2 on 1 minus 2 on 1, brackets x to the power of 1 upon 2. Yep, correct. Plus c2, second constant. Negative, negative, chop off. There's a negative here, sorry. Negative, negative, gone. We have 2 upon root 2. Another way of writing that is 2 root 2 upon 2. 2 to cancel out. We have root 2 x to the power of negative 1 on 2. Correct? Plus c of 2. This is what t is. So t then equals to root 2 upon square root of x plus c2. c2, so when t equals to 0, x equals to 1. Correct? So t equals to 0, therefore 0 equals to root 2 upon 1 plus c of 2, so therefore c of 2 equals to negative root 2. Rewrite this over here. T therefore equals to root 2 multiplied by root x, or we can rewrite this as root 2, dot x to the power of negative 1 upon 2 minus root 2. That is how you do this example over here. Now we'll go on to the next example.